This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at a review of trigonometry. And this is specifically for Calculus 1. A lot of this you've seen already, but just to kind of refresh your memory. My pen to work here. There we go. We have our initial side here, and then we got our terminal side. The amount that this opens up is your angle, and usually it's represented by a Greek letter of some sort, like theta. Some of the examples I'm going to show here, I put the letter D here, just because I was having trouble getting theta in Paint. So realize that most of the times it's Greek of some sort. I'm gonna do this based upon the x and y axis, because we'll get there pretty soon. Here's my initial side. If I go up to there, that's going to be 90 degrees. That little mark there is a degree mark. If this is my initial side, and I go over to here, this is 180 degrees. If I start here, and I go over to here, this is 270 degrees. And if I start here, and I go all the way around, that'd be 360 degrees. Now I can keep on going. I don't have to stop here. I can keep going up to here. And this would be 360 plus 90, 450, I think. And so again, you can just keep going around. If I go around twice, that'd be 720. And those are degrees. Now, if I go starting here and go up to here, this can also be represented, instead of in degrees, can be represented in something called radians. And this would be pi over 2. If I go all the way over to here, this would be pi. If I go all the way down to here, this will be 3 pi over 2. And if I go all the way around the circle, this would be 2 pi. So 2 pi is equal to 360 degrees. It's just in radians. Now, how do you decide what you're working with? Well, if it's got a little degree mark like that, you're in degrees. If it doesn't have it, it's in radians. Now, it doesn't have to have a pi on it. If I had 90 down here, if I didn't put that little degree mark, then it would be in radians. Now, notice I've been going counterclockwise there. If I went clockwise, so I started here, and I ended down here, so I went clockwise. This would be a negative 90 degrees, or negative pi over 2. So if you're going clockwise, then it's going to be negative. Now, we already mentioned, this is talking about the negative angles. You have some angles that are called coterminal. Means they have the same terminal side. Like this one here. If I start here, and I go all the way around to there, that's 360 degrees. If I start here, and I go all the way around twice, that's 720 degrees. They both have the same terminal side. That's going to be important when we're working with a unit circle, because you'll have some that go beyond what's on your unit circle, and you have to either add or subtract 360 degrees or add or subtract 2 pi. Now our first one here, let's take a look at. So you got 50 degrees, more or less. I just kind of eyeballing that, so it's not perfect. So we've got our 50 degrees, and it says determine two coterminal angles in degree measure, one positive and one negative. Well, remember what I said. We can add 360, and that'll give us a coterminal. So we can add 360, and that gives us 410 degrees. We can also subtract 360. So I take 50 degrees minus 360, and that gives us negative 310 degrees. So those would be both coterminal, have the same terminal side. We can do the same thing with radians. Here we got one that's 5 pi over 9. And again, I'm just kind of guessing where that's at. So we can take 5 pi over 9, and we can add 2 pi. Now this is a mixed number. If we ignored the pi's, if you took 2 times 9, that gives you 18, plus 5 gives us 23, and then I'll put the pi there, and then the denominator stays the same. So again, what I did is I took the number out here. 2 times 9 gives you 18, add the 5, gives you your 23. And then the denominator always stays the same when we put the pi back on. Now, just like working with degrees, we can also subtract 2 pi. Because if you add or subtract 2 pi, you're back to where you started anyway. And this is another mixed number. We can take negative 2 here times 9 gives us negative 18 plus 5 gives us negative 13 pi, and our denominator stays the same. That's kind of handy if you remember that little trick there. Let me save this. Calc 1, Trigonometry, Review, page 01.pdf. Oops. There we go. Okay. Now, let's take a look at our unit circle. And I got one here. Of course, a unit circle is obviously a circle, but it's of radius 1. So if we go all the way around here, every one of these points has a radius of 1. Now this, what you see here represents your angles. See how 0 degrees, 30, 45, 60, 90, 120, 135, 150, 180, and so forth, going all the way around. Now, we said here's 0. If I went all the way around, I'd be 360. Another way around would be 720. So we'd end up at the same point on the unit circle if we added or subtracted 360. Now the radian measure. You see how we got 0 pi, 2 pi. Usually you don't write 0 pi, you just write 0. But we have pi over 6, pi over 4, pi over 3, pi over 2, and so forth, going all the way around. And those represent our angles. Now there's points associated with these. Here at pi over 6, we got our x and our y. So this is square root of 3 over 2, this is 1/2. Here at pi over 4, our x is square root of 2 over 2, and our y is square root of 2 over 2, and so on. Now, it's up here in the upper right-hand corner, but it says when you're given a point, like on a unit circle here, our cosine is the first part, and our sine is the second part. Now let me write down the formulas that go along with these, and then we'll look at some problems. If your point is on the unit circle, cosine, and I'll use theta to represent the angle, cosine theta is equal to x, sine theta is equal to y, tangent theta is equal to y over x, Now some of these have reciprocal properties go along with them. Cosine goes with secant. These are reciprocals of each other, which means if this is x, then secant will be 1 over x, because it's fraction flipped. And if I were to put this in fraction form, that'd be x over 1. Now sine goes along with cosecant. If this is y, or y over 1, then the reciprocal of it will be 1 over y. Reciprocal just means fraction flipped. Now this one is tangent, y over x, so cotangent will be x over y. And those are our formulas we'll work with if the point's on the unit-circle. So let's take a look at our next problem. Okay, so we got sine of pi over 3. Now sine is y. That's just from our formulas here. So I'm gonna look on my unit circle at pi over 3. Okay, here's pi over 3. And we said sine is our y. So here at pi over 3 we have this point, and our y is square root of 3 over 2. So our answer to this problem is going to be square root of 3 over 2. Number 4. We have secant of 3 pi over 4. Now from our formulas here, secant is 1 over x. And so we're going to look up 3 pi over 4 on our unit circle. If I come over here, 3 pi over 4 is right over here. And our formula is 1 over x. Well, x is negative square root of 2 over 2. So this, secant is 1 over that, will be 1 over negative square root of 2 over 2. Now if you have a single fraction down your denominator, you can flip it and multiply it times your top part. So, and then 1 disappears, of course. So this becomes 2 over negative square root of 2. Can't have a square root of 2 downstairs, so we multiply top and bottom by the square root of 2. Up on top, I'm going to take this negative and put it up on top. So we got negative 2 square root of 2. Down below, square root of 2 times square root of 2 just gives you 2. These 2's going to cancel, and we got negative square root of 2 as our answer. Okay, our fifth one here. Cosine of 13 pi over 4. Well, for this one, 13 pi over 4, if I go look it up on our unit circle, nowhere do we see 13 pi over 4. It's not on here. It's actually greater than 2 pi. If I think of this in mixed number form, what's that? Goes in there 3 times with remainder of 1. So 3 1/4 pi is what this is. So it's greater than 2 pi. To get it in our unit circle, what we're going to do is we're going to subtract 2 pi. So we'll take that and we'll subtract 2 pi. Because remember what we said. You can add or subtract 2 pi or add or subtract 360 degrees, and your unit circle wise, you're back where you started. So this hasn't changed anything in terms of our unit circle. Now this is a mixed number, so again we could take negative 2 times 4 gives us negative 8, plus 13 gives us 5 pi over 4. And recall, cosine is x if it's on the unit circle. So if I come over here at 5 pi over 4, that's right down here. This seems weird. Let me double check my math. Negative 2 times 4 is negative 8. Yeah, 5 pi over 4. 5 pi over 4 is right here. X is negative square root of 2 over 2. So our answer here will be negative square root of 2 over 2. Let me write down our next formulas. if I have a triangle and we got an angle here, theta. The side opposite of it will be our opposite side. The side adjacent here will be our adjacent side. And here's a 90-degree angle. The side opposite of that will be our hypotenuse. And from our Pythagorean theorem, the opposite squared plus adjacent squared is going to equal to our hypotenuse squared. Okay, so if you have this kind of setup, then sine of theta is going to equal to opposite over hypotenuse. Cosine of theta is going to equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. Now remember, sine and cosecant are reciprocals of each other. So if sine is equal to opposite over hypotenuse, then cosecant will be hypotenuse over opposite. Cosine and secant are reciprocals of each other. So if this cosine is adjacent over hypotenuse, then this will be hypotenuse over adjacent. And tangent and cotangent are reciprocals of each other. So if tangent is opposite over adjacent, cotangent will be adjacent over opposite. And those are our formulas. Let's take a look at our next problem here. And I got D there, but I'm going to go ahead and put theta since I put theta over here. And we got 2 and we got 7. And the instructions say, find the exact value of the 6 trig functions of the angle. Well, here's our angle. The side opposite of it is your opposite side. And the side adjacent to it is your adjacent, so this would be adjacent. Now it'd be different if I put my angle up here, because the side that's opposite of this would be this one here. So you have to look where theta's at. And of course this is our hypotenuse. Now to use these formulas, we need opposite, we need adjacent, and we need hypotenuse. So let's use our Pythagorean theorem here. And we got opposite squared plus adjacent squared is equal to hypotenuse squared. Opposite we said was 2, so we got 2 squared plus adjacent is 7, so 7 squared equals hypotenuse squared. And that gives us 4 plus 49 equals hypotenuse squared, which gives us 53 equals hypotenuse squared. So we'll drop our squared, and we'll put a square root around the other side. And we get the square root of 53. So let's use those then to find the 6 trig functions. So sine theta. We said sine theta is equal to opposite over hypotenuse. Opposite was 2, and hypotenuse is square root of 53. Now we can't have the square root of 53 downstairs, so we'll multiply top and bottom by the square root of 53. So we get 2 square root of 53 over 53 for sine. Cosine is equal to adjacent over hypotenuse. Adjacent we said was 7, and hypotenuse we said was square root of 53. Multiply top and bottom by a square root of 53, and we get 7 square root of 53 over 53. Tangent is equal to opposite over adjacent. Opposite we said was 2, adjacent we said was 7, so that'd be 2 7s. Now we can use the reciprocal identities to do the other ones. And yeah, I might have room right here. Out of room at the bottom. Cosecant goes along with sine, and it's a fraction flipped. Now you want to flip the appropriate fraction. If I flip what I circled, that's not going to work well. But if I flip this one right before it, 2 over square root of 53, then we'd get square root of 53 over 2, and we're done with that. Secant is cosine flipped. Well, again, I don't want to pick the one I circled, but the one before it, 7 over square root of 53. If I flip that, I get square root of 53 over 7. And cotangent is tangent flipped. This is 2 sevenths, so this would be 7 halves. Let me save that. I think that was that only problem on that. Yes, it was. So this next type is where you have a point that's not on your unit circle. So let me show you the setup. We have our initial side here, and then you have your point here, and it's not on the unit circle. Now this distance here would be r. And I could find that using the Pythagorean theorem. And what it would give us is that r squared is equal to x squared plus y squared. Or r is equal to square root of x squared plus y squared. Depending upon the setup of the problem, this first formula may be easier to use, or the second formula may be easier to use. Okay, point not on the unit circle. Our formulas: sine is equal to y over r, cosine is equal to x over r, tangent is y over x. Now cosecant is the reciprocal of sine, so if sine is y over r, this will be r over y. And secant is the reciprocal of cosine, so if that's x over r, this will be r over x. And cotangent is the reciprocal of tangent, so if this is y over x, this is x over y. And let's look at our first problem here. Okay. So we're given the point -2, 5. And it says determine all 6 trig functions for the angle. And it says d, but you know, d, theta, doesn't matter. This I didn't write it here, but actually theta would go right here. Okay. Well, this is of course our point, so this is x, and this is y. Now, to use these formulas, we need x, y, and r. So let's go ahead and find r. And the second formula is easiest to use here. So we got r is equal to the square root of x squared plus y squared. So r is equal to x is -2. So we got -2 squared plus y, which is 5, so plus 5 squared. That's 4. This is 25, so that gives me square root of 29. Okay. Sine. We said sine is y over r. Y is 5. R is square root of 29. Can't have the square root downstairs, so we multiply top and bottom by square root of 29. So we get 5 square root of 29 over 29. Cosine is equal to x over r. Well, x we said was -2, and r is square root of 29. Again, we can't have the square root of 29 down below, so we'll multiply top and bottom by that. So that gives us -2 square root of 29 over 29. Tangent is equal to y over x. Y is 5 over x, which is -2. So we got -5 halves. And again, we'll use our reciprocal identities to find the other ones, make it a lot easier. Sine and cosecant go together. So and I'm going to pick the appropriate fraction. The one I circled isn't a good one, but this one before it is. So if I flip that, I get square root of 29 over 5 for cosecant. Now, you want your square root up on top, so that's why you have to pick the appropriate one if you want to save yourself work. Now, cosine and secant go together. So again, I'll flip this fraction here, the negative 2 over square root of 29, and that gives us negative square root of 29 over 2. Doesn't matter where you put the negative. And tangent and cotangent are reciprocals of each other. So if that's negative 5/2, this will be negative 2/5. And those are our answers. Let's take a look at this next one. Number 8. Part A, it says sine theta is greater than 0, and cosine theta is less than 0. And instructions say determine the quadrant in which theta lies. Now remember, sine is our y. No matter what formula we use, if we use a point on the unit circle, sine is y. If we use a point not on the unit circle, sine is y over r. But r is always positive, so we can ignore it anyway. So we're saying y is greater than 0. Well, that's in these two quadrants. And cosine is x, so we're saying x is less than 0, so we're saying x is negative. Well, x is negative in this quadrant and this quadrant. Now, where they're both true is in quadrant 2. So that'd be our answer. Now B says secant theta is less than 0 and tangent theta is less than 0. Well, secant was, just in terms of on our unit circle, was 1 over x, or if not on the unit circle, r over x. But again, r we can ignore. So basically we're looking at x. That's saying x is less than 0. X is negative, which is right here and right here. Now tangent. Tangent is y over x. Well, if these are the same signs, both positive or both negative, then this will be positive. Because a 3 over 4 is positive, a negative 3 over negative 4 becomes positive. This is saying the tangent is less than 0. Tangent is negative, which means the only way you can get a negative out of this is if one of these are positive and one's negative. So the signs are different. Well, the signs are different for tangent in the second quadrant and the fourth quadrant. So where they're both true is quadrant 2 again. And that's our answer. And let me save that now. I'm not sure if I have room for the next problem on this. There we go. Okay, let's take a look at this one. We've got sine theta is equal to 2 over 7. And it says theta is in quadrant 2. Quadrant 2, let's think where that's at. That's right here. In this quadrant here, x is negative and y is positive. And then instructions say use the x, y, and r formulas to find the following. And then what's this find tangent? Well, from this, recall, sine is y over r, which means y is equal to 2 and r is equal to 7. Now, when you're using these x, y, r formulas, you need to find x, y, and r. Well, we need to have these two. So we got x squared plus y squared is equal to r squared. That's one of our formulas. So let's plug in what we know. We said 2, or y was 2, so we got x squared plus 2 squared equals, and r is 7, so we got 7 squared. Well, 2 squared is 4, 7 squared is 49. We'll take 4 over to the right side, it becomes a negative 4, which gives us x squared is equal to 45. And drop the squared, put a plus or minus square root around the other side. And 45 is 3 times 3 times 5. Remember the square root, we're looking for a pair of somethings. Here's a pair of 3, so it's going to come out. And we get x is equal to plus or minus 3 square root of 5. Now look what quadrant we're in. We're in quadrant 2. In quadrant 2, the x values are negative. So our x is just going to be negative 3 square root of 5. You have to use the quadrant you're in to figure out what your sign is going to be. Now what we're wanting is we want tangent. That's just from our problem. It says find tangent. And remember, tangent is equal to y over x. Well, y we said was 2, and x is negative 3 square root of 5. Can't have the square root of 5 downstairs, so multiply top and bottom by it, and I'll put this negative up on top. So I got negative 2 square root of 5 over, this would be 3 and square root of 5 square root of 5. Which gives us negative 2 square root of 5 over 15. Because square root of 5 times square root of 5 gives you 5. And that's our answer. Okay, let's take a look at another one of those. Okay, cotangent equals 5, and sine is less than 0. And we want to find secant. Well, we'll come back to that. Let's first talk about the quadrant. Sine, remember, was y. So this is saying y is less than 0. Y is negative. Well, y is negative here and here. Cotangent is positive. Cotangent is equal to x over y. Well, cotangent's positive. See, because it's equal to positive 5. So cotangent is positive when the signs are the same, which is either here or here. So where they're both true is in quadrant 3. Now in quadrant 3, x is negative and y is negative. So we'll need that piece of information. Okay, so cotangent, if I were to put it in fraction form, is equal to 5 over 1. Because you can always create a fraction by putting it over 1. And we said cotangent is x over y, and x is negative and y is negative. So that means that x is equal to negative 5 and y is equal to negative 1. Now we need r, so let's find r. So we got a formula that works out best for this. We got r is equal to square root of x squared plus y squared. So square root of negative 5 squared plus negative 1 squared, which gives us square root of 26. Now what we want, I forgot, let's see, secant. So we want secant. And secant is r over x from our formulas. R we said was square root of 26, and x we said was negative 5. So secant will equal square root of 26 over negative 5. Now these next ones are calculator problems. Grab a drink here, I'm getting thirsty. There we go. Okay, we got sine of 20 degrees. Go to my calculator here. I'm in graph mode, so I'm going to exit out, do a second mode. And if I press mode, it'll bring this up. And you see the third one down says radians and degrees. If I down arrow to that line and press my right arrow, put my flashing cursor on degrees and press enter, that'll highlight degrees. Well, now if I exit out, I'll do second mode To find sine of 20 degrees, you press your sine button here, put in your 20, and enter. And to 4 decimal places, this will be 0.3420, and that's our answer. Number 12 is cotangent of 35 degrees. Now on our calculator, we're already in degrees, so we don't need to set that again. But if I look at my buttons here, nowhere do I see a cotangent. But remember, the cotangent and tangent are reciprocals of each other, which means I can rewrite this as 1 over tangent, 35 degrees. And that I can plug in. So I do 1 divided by tangent 35. And even though I'm not putting a degree mark, the fact I put myself in degree mode first, it assumes degrees. And I press enter. And my answer would be 1.4281. And one more calculator one. I want to find cosecant of pi over 5. Now notice this doesn't have a degree mark on this, so this is in radians. Now if I look on my calculator to begin with, I don't see a cosecant button. So again, we have to use a reciprocal. I know cosecant goes along with sine, so I can rewrite this as 1 over sine pi over 5. Okay. Now to plug this in our calculator, let's go change ourselves to radians. So I'll press mode. I'm going to down arrow to the line that says radians and degrees. My flashing cursor is currently on radians, and I'm going to go ahead and press enter on that. And that'll highlight radians now. So I'll exit out, do a second mode, and I'll do 1 divided by sine. Pi is above your caret here, so you do second caret, and then divided by 5. And enter. And that gives us 1.7013. And that's our answer. Now let me talk about some of the basic identities that are real handy to know for Calculus 1. We've already kind of been referring to this over and over, but if you have sine theta, that's equal to 1 over cosecant theta. What goes along with that is if you got cosecant theta, that's equal to 1 over sine theta. If you got cosine theta, that's equal to 1 over secant. Cosine and secant are reciprocal identities. And secant, or reciprocal functions I should say, secant is equal to 1 over cosine. Tangent is equal to 1 over cotangent, because again those are tied together. And cotangent is equal to 1 over tangent. Also, tangent theta is equal to sine over cosine. And cotangent theta is equal to cosine over sine. Now we have our Pythagorean identities. And the first one is sine squared plus cosine squared is equal to 1. Now this is the only one I actually have memorized. From this one, whether I write it down or whether I envision it in my head, I can easily come up with the other ones. If I divide everything by sine squared, then I'm going to end up with sine squared divided by sine squared is 1, plus cosine squared divided by sine squared. Cosine over sine is cotangent, so this will be cotangent squared. And if I divide this by sine squared, I get 1 over sine squared. 1 over sine is cosecant, so this would be cosecant squared. If I go through my sine squared plus cosine squared is equal to 1, divide everything by cosine squared. Sine squared divided by cosine squared, sine over cosine is tangent, so this will be tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared would be secant squared. So very easy to come up with those. You don't have to actually have them memorized. You can derive them in your head each time. Let me save those. Look at our first trig equation here. Okay, we've got sine theta is equal to negative square root of 2 over 2. And this is from 0 to 2 pi, so it's just on our unit circle. And it says solve it. So we want to find out what theta can we put in here that would cause this to be true. Well, if we go to our unit circle, remember what sine is. Sine is your y. So we're going around our unit circle, and we're looking for where y is equal to negative square root of 2 over 2. Well, down here at 5 pi over 4, y is equal to negative square root of 2 over 2. So our first answer is 5 pi over 4. There's one more place where y is equal to negative square root of 2 over 2, and that's here at 7 pi over 4. So those would be our two answers. So again, we're going around the unit circle looking where our y value is equal to negative square root of 2 over 2. Now number 15. We got 2 cosine theta plus 1 equal to 0. Now our goal here is to get the trig function by itself. If you have a single trig function, you want to get it by itself. So I'll take the 1 over. So we've got 2 cosine theta is equal to negative 1. And then divide both sides by 2. And we get cosine theta is equal to negative 1/2. Now remember, cosine is your x. So we're going around our unit circle, and we're looking where x is equal to negative 1/2. Well, and we know what cosine is. Cosine is x, and the only places where x is negative is in quadrant 2 and quadrant 3. And we're looking for the x value specifically. So here's one place where x is equal to negative 1/2, and that's 2 pi over 3. Another place where x is equal to negative 1/2 is right down here, which is 4 pi over 3. So those would be your answers. Let's talk about this one. And we'll put it down here. I want to have some room. Okay, so we got tangent theta is equal to negative 1. Well, this is not so easy. Sine and cosine are really easy when you're solving trig equations because they just correspond to our x and our y. But tangent, remember, is y over x. Well, let's look on our first quadrant here, on our inner circle. Here, this point here is square root of 3 over 2 and 1/2. This point here is square root of 2 over 2 and square root of 2 over 2. And this point here is 1/2 and square root of 3 over 2. Now tangent is y over x. Okay, so if I put this y over this x, I would end up with square root of 3 over 2 over 1/2. And the 2's would cancel since they're the same, and I have square root of 3 over 1, or this would just be square root of 3. On this one, y over x, square root of 2 over 2, over square root of 2 over 2, which would just give us 1. And then down here, y over x, I would have 1/2 over square root of 3 over 2. 2's go away, and I'd have 1 over square root of 3, which if you multiply top and bottom by square root of 3, would give you square root of 3 over 3. Okay, Well, what we're looking for is negative 1. So it looks like we're interested where the values are both square root of 2 over 2 and square root of 2 over 2. Okay. Here's one place, pi over 4. Here's another place, 3 pi over 4. Square root of 2 over 2, square root of 2 over 2. 5 pi over 4. Square root of 2 over 2, square root of 2 over 2. And 7 pi over 4. Square root of 2 over 2 and square root of 2 over 2. By looking at your first quadrant, if you got a value like this, you can see the point setup you want. Now, specifically on this one, this is a negative 1, which means they have to be different signs. Well, if I come over here, here's negative square root of 2 over 2, here's positive square root of 2 over 2. Different signs. So our first answer is 3 pi over 4. There's one more place. Here they're both negative. One more place. It's over here. See how this is positive square root of 2 over 2, and this is negative square root of 2 over 2. And that's at 7 pi over 4. So those would be our answers. Number 17. We got cotangent theta is equal to square root of 3 over 3. Okay, well, let's look at our first quadrant to kind of get a feel for this again. Okay, this point here is square root of 3 over 3, and wait a minute. Square root of 3 over 2 and 1/2. This is square root of 2 over 2. This is square root of 2 over 2. Sorry, I'm listening to something in my house. That's a weird sound happening. And 1/2. And this is square root of 3 over 2. Now, cotangent is x over y, which is the reciprocal of this. What we're going to find if we go through it is this one is going to be square root of 3 over 3, or square root of 3, sorry. And this is 1. And this one is going to be square root of 3 over 3. So they just kind of, these two flip around. Well, we're looking for square root of 3 over 3, which looks like occurs when we got 1/2 and square root of 3 over 2. We got 4 places for that. Here's 1/2 square root of 3 over 2. Here's negative 1/2 square root of 3 over 2. Here's negative 1/2 negative square root of 3 over 2. And here's positive 1/2 negative square root of 3 over 2. It'll always be that way by the symmetry. Now, specifically in this one, this is equal to a positive. And the only time this is positive is when the signs are the same. Because remember, like a positive value over a positive value gives you positive. Negative over a negative gives you a positive. So if we go around our unit circle, obviously this is one of them, pi over 3. And our other place is down here. And again, we're looking for the 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. That'd be 4 pi over 3. Now again, x over y. If I were to put this x over this y, negative over negative becomes positive. Let's take a look at the next one. Okay, so we got 2 cosine squared equals 1. This is again in our unit circle. Well, we want to get the cosine squared by itself, so I divide both sides by 2. And from college algebra, we had the square root property. It says that if you have something squared equal the other side, you drop your squared. So we'll drop our squared, and we'll put a plus or minus square root around the other side. Well, we can't have a fraction inside of a square root, if you remember that from intermediate algebra, so I'll split it up. I'll put a square root around top, square root around the bottom. Square root of 1 is 1. And we also know we can't have a square root down denominator, so we'll multiply top and bottom by square root of 2 to get rid of that. So this becomes plus or minus square root of 2 over 2. Now remember, from our unit circle, cosine is x. So if I go around, I'm looking for where x is equal to positive square root of 2 over 2 or negative square root of 2 over 2, which is 4 places. Here's one place where x is square root of 2 over 2, so pi over 4. Here's another place where x is either positive or negative square root of 2 over 2, 3 pi over 4. Then down here, 5 pi over 4, it's also equal to that. And then the last one is 7 pi over 4, which is right here. It's equal to a positive square root of 2 over 2. So those would be your answers. Let me save that. There we go. And let's look at our next problem. Number 19. We've got 2 sine squared minus sine minus 1 equal to 0. And same instructions. It's on find it on the unit circle. Well, this one can factor. Now, some people have trouble with these. If you have trouble with these, go over here on the side and replace your trig function with just a variable of some sort. So I'll put p in for sine. So this would be 2p squared minus p minus 1 equal to 0. And then factor this. This factors as 2p, p, 1, 1, minus, plus. Now, after you've factored this, we didn't really have p. We had sine there. So go back and put sine where we have a p. So this becomes 2 sine theta plus 1 times sine theta minus 1 equals 0. Now from college algebra, if you got 0 on one side and you factor the other side, the zero factor property says you set each factor equal to 0. So I'll set 2 sine theta plus 1 equal to 0, and I'll set sine theta minus 1 equal to 0. And I'm going to solve each one of these. I'll get the sine by itself. So here I'll take the 1 over. So we got 2 sine theta is equal to negative 1, or sine theta is equal to negative 1/2. And on this one, I'll take negative 1 over, and we get sine theta is equal to 1. Okay, let's first look at the negative 1/2. We're looking where sine is equal to a negative 1/2, which is going to be in quadrants 3 and 4. So if I come down here, sine is our y on our unit circle. Remember that. It's equal to negative 1/2, the y value, right here. 7 pi over 6 is one of our answers. Another place is over here. Sine, which is our y, is equal to negative 1/2, which is 11 pi over 6. Now here, we're looking where sine is equal to 1. Sine, again, is our y value. Here, our y value is equal to 1 at pi over 2. So those would be our answers. And let's look at our next one. So we got cosine theta is equal to secant theta. And let me scratch my eyes here, or eye. My eye's itching. Okay. Now, if you got 2 different trig functions, one technique you can use is you can use your identities to rewrite them so they're both the same. For example, secant we know is equal to 1 over cosine. So I could rewrite that as 1 over cosine. Now, since the beginning of your math, whenever you're solving equations, you always get rid of fractions. You did that in elementary algebra, intermediate, college, trig, and it's always the same. You always get rid of your fraction by multiplying everything by the LCM of all your denominators. We only have one denominator, the cosine, so that's our LCM. We'll multiply everything by cosine. So we've got cosine theta times cosine theta equals cosine theta times 1 over cosine theta. Those are going to cancel there. And cosine times cosine gives us cosine squared equals 1. And this is square root property from college algebra. If you got something squared equal to the other side, you drop your squared, and you put a plus or minus square root around the other side. Now square root of 1 is just 1, so we get cosine is equal to plus or minus 1. So we're going to go around our unit circle, and we're going to look where cosine, which is our x, is equal to either a positive 1 or negative 1. Well, it's equal to a positive 1 here at 0, and it's equal to a negative 1 over here at pi. And those would be our answers. And I probably have room there, but let me save this, and then I'll do the last problem. So I may throw another one in there, showing it on the calculator. Okay. And let me grab a drink here. Let's take a look at this one. You run across a few of these in Calc 1, and people have trouble. Students have trouble with them. Okay, so we got cosine 2 theta is equal to square root of 2 over 2. Now, you can use your identities to rewrite this. This is a double angle, but there's a lot easier way, and sometimes you can't even do that. What I mentioned. What we're going to do is we're going to look where cosine is equal to square root of 2 over 2. And so let me. Cosine is equal to square root of 2 over 2. Cosine is equal to square root of 2 over 2. Cosine is equal to square root of 2 over 2. Cosine is equal to square root of 2 over 2. One more. And cosine is equal to square root of 2 over 2. Why did I do this many? We'll get back to that. So we're looking on our unit circle where cosine, which is our x, is equal to square root of 2 over 2. Okay. Here's our first one. X is cosine. It's equal to that at pi over 4. So that's one place. As I go around my unit circle, come down to 7 pi over 4. Cosine, which is our x, is also equal to square root of 2 over 2. So this would be 7 pi over 4. Well, I know that I can add, I'm here at pi over 4. If I go all the way around and add 2 pi to that, I'm going to be back here. So it's also equal to that at pi over 4 plus 2 pi. If I'm here at 7 pi over 4, I know if I add 2 pi onto it, I'm back to where I was. So this will be 7 pi over 4 plus 2 pi. And I know if I'm at pi over 4, if I add 2 pi, I'm back here. If I add another 2 pi, I'm back here. So we can add 4 pi. You can actually add any multiple of 2 pi. Okay, so what we got is we got cosine of pi over 4 is equal to square root of 2 over 2. We got cosine of 7 pi over 4 is equal to square root of 2 over 2. And this one, this is a mixed number. I can take 2 times, there's like an invisible 1 up here. I can take 2 times 4 gives me 8, plus the 1 gives me 9 pi over 4. And that's equal to square root of 2 over 2. On this one, 2 times 4 is 8, plus 7 is 15, so we got 15 pi over 4 is equal to square root of 2 over 2. And on this one, 4 times 4 is 16, plus the 1 gives us 17. So that's 17 pi over 4 is equal to square root of 2 over 2. Okay, let me double check this. 2 times 4, 8, 15, 8, 9. Okay. Well, that'd be okay. These would be our answers if this was theta, but it's not theta. It's 2 theta. So what we're going to do is we're going to take this 2 theta and we're going to set it equal to pi over 4. So I got 2 theta is equal to pi over 4. We're going to take that 2 theta and we're going to set it equal to 7 pi over 4. So 2 theta is equal to 7 pi over 4. We're going to take that 2 theta and we're going to set it equal to 9 pi over 4. We'll take the 2 theta, we'll set it equal to 15 pi over 4. I'll go ahead and this one too. So 2 theta is equal to 15 pi over 4, and 2 theta is equal to 17 pi over 4. Okay, now we want to solve for theta. We can multiply both sides by 1/2. So this gives us theta is equal to pi over 8. That's our first answer. This one, if I multiply both sides by 1/2, I get 7 pi over 8. This one, if I multiply both sides by 1/2, I get 9 pi over 8. You see the pattern, right? The 4 that's in the denominator just becomes 8. So this one is going to be 15 pi over 8. Now this one will be 17 pi over 8. 17 pi over 8, that's equal to 2 1/8 pi. That's gone past 2 pi. Remember, our original problem said between 0 and 2 pi. So this one's gone past 2 pi, so we can't use that one. So our only answers are these ones right here. So those are our 4 answers. Now the way it works is if I have 2 theta here, the 2 tells me I'm going to have 4 answers. If I have 3 theta here, I'm going to have 6 answers. If you have 1/2 theta here, you actually only have 1 answer. And if you have like 1/5 theta, I have no clue what you're going to have. I'm guessing 1 answer, but maybe not. I haven't done enough of them to really be comfortable with telling you that. But I've done enough of these 2 thetas and 3 thetas to know what you're going to come up with. I knew I didn't need this last one. I just wanted to show that it went past 2 pi. So those are our 4 answers for that particular problem. Okay, let me make up one. And hopefully this has an answer. Otherwise I'll have to modify it a little bit. Let's see, cosine theta is equal to 1/8. That should have an answer. Okay. And, well, nowhere on our unit circle, if I go look, cosine is our x, nowhere does the x value equal to 1/8. So this is not our unit circle. One of the ways we can solve this is using our calculator, using the intersect method. Now, in order to do that, you have to have everything over on one side. So I'll take the 1/8 over, like that. And we're going to put this on y1, and we'll put this side on y2. So let's take a look at that. I want to make sure I'm in radians. So if I press mode, I am in radians. Usually in calculus, you put your answers in radians. Okay, I'll do a second mode to exit out. To do our intersect method, I'll press y equals, press clear to clear out whatever's on y1, and we say we're going to put this in there. Now we don't have to put theta, we can put x. So if I press cosine and I'll press this key, it'll put our variable, closing parentheses, minus 1 divided by 8. Now down arrow to y2, and I'll put a 0 here. Now to begin with, I want to set myself up such that it's easiest to work with. So I press zoom, and I want to choose Z trig, number 7. And I can either down arrow to it and press enter on it, or just press the number 7, the number's in front of it. And this will set it up from negative 2 pi to positive 2 pi. Okay, that's assuming we're looking for answers from 0 to 2 pi. I'm only interested on the right-hand side here. I don't care about the left side. And our answers are going to be where it crosses the x-axis. So you see it crosses the x-axis in 2 places. Well, let's find our first one. We're going to do second, trace, and we're going to choose intersect, so press number 5. Now it'll come up and ask us for our first curve, and we'll press enter on that. It'll come up and ask us for our second curve, so we'll press enter on that. Now if it won't let you go past either the first curve or second curve, it probably means you don't have 0 on y2. So go back and put 0 on y2 and it'll let you go past it. Now it's asking us for our guess. Now I see my flashing cursors here in the middle. I'm going to press my right arrow key until my flashing cursor is closer to the one I want to find. And I put that almost on top of it. Once you get it closer to the one you want to find, you press enter, and it'll come back and it'll tell you your answer. Now this is an approximation. I'll take it to 2 decimal places, I guess. So that's 1 point. I don't know what happened with that green there. 1.46. No, 1.45. My boy, that blew my mind with it turning green. Must be something with my display. So that's our first answer. Well, our second answer is over here. So we go through the process again. We're going to do second, trace, choose 5 for intersect. I'll do enter on first curve, enter on second curve. Look where our flashing cursor is. I want to move it over closer to the one I'm trying to find. So I'll move it over here. We're actually going to see in Calc 1 how to use a derivative to find this. Now we're over here now. So I'm going to press enter, and it'll find the one that's closest to it. It doesn't have to be right on top of it. Don't like make it too far away, but it'll go and find whichever one is closest to. And it just found that. So we got 4.84. And those will be our answers. And that's the end of this lesson, so let me go ahead and stop the recorders. And actually, I better save this too, or I'll forget. So I've done that before. There we go. And let me stop the other recorder.